Awesome. Looks like we're all set. So without further ado, thanks everybody for attending the Chainlink workshop, last workshop of the day today, the first day of MarketMake. We've got Patrick from the Chainlink team, who's going to come at you live with a bunch of info on how to use Chainlink, get data into your contracts, into your dApps, and of course, many, many, many other things. So Patrick, I'll turn it over to you.
Awesome, thanks so much. Yeah, I'm just going to go ahead and share my screen. I just had to retweet the MarketMake tweet. Can everyone see this?
Looks awesome.
All right, great. All right, awesome. So what's going on, everybody? My name is Patrick. I work on the Chainlink project. I'm really excited to be here. Really excited to be helping out with the ETHGlobal team's hackathon. They always put on a stellar event. I'm really glad that I've been invited back. So yeah, I'm here to talk to you about Chainlink, about decentralized oracles, about data, and about building the next generation of smart contracts. At this exact point in time, we really have an extraordinary opportunity in front of us. The world of smart contracts is right here. We're seeing more and more adoption and more people understanding why smart contracts and why blockchain is so important and how it can really change the whole world for the better. So we have this opportunity. We have this obligation almost to do something fantastic and build really cool things. And these hackathons are really the stomping grounds that enable this creativity, that enable everything that we're doing here. So I will be monitoring chat from time to time. So if you have any questions, feel free to pop them in there and I'll get to them when I can. So let's continue on. So a brief kind of layout of what we're doing here. We're going to talk about the Oracle problem, some definitive truth for financial data, verifiable randomness functions, accessing any APIs, use cases, and then we'll get into some demos at the end. So in order to really understand Chainlink, we first need to understand that smart contracts are not able to connect to external data or really any off-chain data resource on their own. And this is a huge limiting factor for smart contract adoption, because it means the only thing that we can really do is token transfers with each other. And that doesn't sound very smart contract-y, right? Because a smart contract is just a traditional contract that can do more things, and it is decentralized and it auto executes and it's not corruptible, which doing token transfers is great, but we obviously want to do more than that. So one of the questions that I often get asked is, okay, well, why can't I just make an API call in my smart contract? This is actually a really important question, and the simple answer is that blockchain is a deterministic system, and it needs to be able to be validated from the inception, the genesis block, all the way to where it is right now. And if making API calls is part of that validation, part of that consensus protocol, then each node is going to get wildly different results when trying to sync up, right? Because if one node calls an API, a minute later, that API could be changed, could be depreciated, and if you try to go back and 20 years later, try to revalidate every single node, every single transaction, it's going to be all whack and it doesn't work. So how do we deal with this problem? So to interact with the outside world, we need what's called an oracle. An oracle is any device that interacts with the off-chain world to provide data to smart contracts, and they report the result of this data in a transaction on-chain so that the blockchain can stay deterministic. So these are really, really important, obviously, because they take these smart contracts from kind of being these tokenized transactions to being able to take real data and build real contracts that have real meaning. Now, here's where it gets a little bit spicier, the oracle problem. A centralized oracle becomes a single point of failure for the entire smart contract. If you have a centralized data source, but a decentralized logic, your smart contract isn't decentralized. One of the main reasons that we build on blockchains at all is because of the decentrality. So if we have our logic that's totally decentralized, that's fantastic. If we get our data component of our smart contracts from centralized points, it kind of defeats the purpose. So in order to make our applications that truly never need to rely on one entity, be it a company, a landlord, government, or anything like that, you need a network of Chainlink nodes. You need a network of Chainlink oracles, and we use those terms a little bit interchangeably. So to answer all this, Chainlink is a decentralized Oracle network. It's a modular decentralized Oracle network, meaning you can build your networks to be as decentralized as you want and add as many nodes, getting data from as many different data sources as you can, so that your data can be truly decentralized and tamper-proof with these auto-executing smart contracts. And this is where Chainlink really shines. So Chainlink allows users to build anything that they want and take smart contracts from doing just these token transfers to being what we really want smart contracts to be, and replace and re-landscape entire industries right now to doing these superior digital agreements, because that's what smart contracts are. The added trust, reliability, and security of smart contracts is something that we need in today's day and age. And Chainlink allows you to do that. Chainlink is completely customizable and can work with any API. And there's even more, it's even more customizable with what's called external adapters and external initiators. These are what allow people to connect to any blockchain or any data source and have the nodes do hypothetically whatever you want. And to get you started with DeFi, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet and combined their prowess to build what's called price feeds. These are decentralized on-chain reference points that can be considered source of truth for various currency pairs, like the price of ETH and USD, for example. And as you can see, this image is a little bit outdated, but everything is the same. Each node, because ETH is not $200 anymore, each node in the network independently retrieves data from some of the highest quality data APIs and reports their answers on chain. You can see the answers that each provider reports so that everything is completely transparent. Many of the most popular cryptocurrencies or fiat pairs are currently supported. And the best part is, if you don't like it, you can build something else yourself. Now, so here's just a little bit more of the approach of how these price feeds work. Or the thought and the care that goes into making sure that these are so powerful. They're centralized, provably secure. They're all using high quality data. They use crypto economic security. There's defense at depth. Huge open source community that's contributing. If you want to learn more about it, definitely check out the documentation, and you can kind of read into the actual oracles and the actual nodes that are running these price feeds. And why I'm stressing this point so much is we've already seen dozens of attacks, and just in November alone, when I was counting, I counted 6 attacks in DeFi that were over $1 million each, and they were due to the fact that they were using centralized oracles. So we absolutely need to raise us as a community to a higher standard and use safer decentralized oracles so that we can build these awesome protocols and these awesome projects. And DeFi is constantly, one of the major areas pushing for projects and pushing for innovation and really drawing out the creativity of engineers, and has a ton of momentum and knowledgeable people working in the field. Chainlink supports some of the top DeFi projects already. At the moment, there's over something like $20 billion in DeFi. And you may think, oh, we're doing really well. That's a lot. It's not even close to what traditional finance is. So there's so much ground to be built. And so some of the projects that are using Chainlink right now, Chainlink price feeds, are synthetics with over $1 billion in assets under management. Loopring, Set Protocol, Aave with what is it, like 3 billion right now or something like that. So these synthetic price feeds are battle tested, tried and true, to really give you these definitive sources of truth on financial data, like price feeds. There's more data than just the prices of ETH and different cryptocurrencies. You can definitely check it out in the documentation, or you can go to feeds.chain.link to see the visualizations, learn a little bit more about exactly what's going on under the hood and everything else going on there. So with that as well, Chainlink is more than just price feeds. Chainlink is, like I said, it's an oracle that allows really any input and any output, and you can really do whatever you want. You can take your smart contract from being an agreement to just send tokens to doing anything that any contract on the planet does today. This is the future that we want. This is the potential of smart contracts to really do everything regular contracts do today. And, obviously contracts play a huge role in our lives pretty much everything you're looking at is a result of a contract. The computer that you're watching this on, or maybe you're streaming it from your phone, is a result of many contracts to get the materials, to build the materials, to build the software. These are all due to contracts. So, going from regular contracts to these smart contracts to these superior digital agreements is a huge advantage for humans and the world in general. So Chainlink allows you to do any input and any output, and a huge use case here is getting provably random numbers. Right now, what a lot of people use to get random numbers is they use a little bit of they depend on the block hash, and they hash the block hash. But right now, that's not a really safe way to get a truly random number. If a miner is incentivized to get a different random number, they cannot publish a block, which actually screws with the fairness of your supposedly provably fair random application. So we can't trust the miners. We can't have this system where we're working on the block hash to get a random number. So we need a better solution. And this is where Chainlink VRF comes into play. Chainlink VRF is a provably random function generator. So it provably creates random numbers that are verified on chain that they're provably random. It was developed by some very intelligent people. Saying provably random sounds insane to me. But yeah, all the code is open source. You can go check it out and learn how this actually works. There are a number of projects that are working with this Chainlink VRF and are using Chainlink VRF. One of them being pulled together. Everything is in the documentation. You can start getting random numbers right now to power your gaming, your random sampling, or whatever you want to do with random numbers. And again, Chainlink is capable of being used to work with any API and can be extended to integrate with any blockchain with external adapters and external initiators. So this is really the power of Chainlink. Everything that you know and love about the internet, right now it runs off of APIs. You can take those exact same APIs that makes the internet run, customize them however you want, and put them into your smart contracts. And you can do it in a decentralized fashion. And then here's a snapshot of the docs page of the Chainlink API calls, which we'll get to in just a minute. But really quickly, before we do that, I wanted to just run through a few sample use cases of what you can do with Chainlink-enabled smart contracts. There's a blog out there called 77 Smart Contract Use Cases Enabled by Chainlink. I highly recommend checking it out if you're kind of looking for ideas or looking for something to do. This industry is still, I know it's been, what, 6 years since Ethereum launched. There's still so much innovation to be done and so many protocols to be built in a decentralized fashion. Let's just rip through a couple of them. Decentralized finance. Again, I know this is a big topic, but there's still so much to be built in this area and so much to do and so much to be learned here. Fantasy sports or any sports game in general, any type of poker game or any type of RNG game or literally any game at all. Any type of tokenized assets, split up your car, plots of land, making it real. Chainlink makes it really easy to keep track of who owns what, and you don't have to deal with any of that paperwork. And since your data is coming from a decentralized source, no one can mess anything up. And then obviously insurance is a huge one that I'm really excited for more projects to get into this space. Let's say your crops are messed up due to the weather and your insurance doesn't want to pay out due to some pre-existing condition or something. Well, with a decentralized smart contract and a decentralized insurance platform, you don't have to trust that the insurance company is going to do the right thing, because doing the right thing is infrastructural with Chainlink. So with that, it looks like we have plenty of time to go through a couple of demos. And let me answer a couple of questions before I go on to that. Oh, looks like there are no questions. Hello. Stream up. All right, cool. Yeah, feel free to ask any questions during this. I'd like this to be kind of a more interactive session. So if anything is confusing, feel free to let me know here. Let me switch gears to this. Okay, so we're going to start on the documentation page. So this is the Chainlink docs. This is where most of you engineers are going to come to just start learning about your projects. We are going to go and start with the price feeds. So each section is kind of separated like this. Let's go to price feeds. You can learn more about what each of the price feeds does here. And all the code is here, everything that you want to do. We can actually just go ahead and click this big remix button. and we can get a demo spun up right in Remix. And this is going to be getting the latest price of an asset. So again, if we head over to feeds.chain.link, we can see kind of what these feeds look like once my computer decides to load. Or I have to make it wider. We can see what these feeds look like, and we can see the different nodes reporting their different individual prices. That all gets aggregated to this number right here, and we can even click on it. We go check it out on Etherscan. Everything that we want to know is here. We're going to look at these internal transactions, and we can see it gets updated pretty frequently, which is really exciting. So on on Remix here, I've done this a few times, so I have a couple different contracts here. We hit that button, and the code's automatically populated right here. And this is everything that we need to know. So first, we're going to import the code from the Chainlink GitHub, and this is going to be how we define connecting to the price feed that has this decentralized price. Something else actually that I didn't put in this demo that I probably should is for those of you who want to try using ENS. ENS is now enabled, which is really, really exciting. You can actually just use ENS instead of these address strings, which is really exciting. So we're on the Coven test network right now, or we should be. I'm on the Mumbai test network, actually. Got to reload the site. Test password. And can you guys see MetaMask? Or can we not see MetaMask?
Yep, it shows up.
It shows up? Okay, great. All right, cool. So, so we're on the Coven test network here. I have already gotten my test ETH and my test link and a whole bunch of other stuff in here. If you need to know, if you need to get a faucet to get test Ethereum or test Chainlink, you can find that in the documentation too. You can also go through these tutorials if you're brand new and you're still learning. This will also go through giving you some testnet ETH and some testnet link so that you can get spun up and learn how to deploy a smart contract, right now and on a testnet, which resembles very closely to the Ethereum mainnet. I got a question, so I'm going to take it. How would it work to get IoT data into a smart contract? Even Chainlink couldn't help to get data, for example, data from temperature sensors, right? If there were, for good examples, in one, a supply chain and cooled goods. You could just put one sensor in a cooling box inside a truck and put the other goods outside the box. Maybe I didn't read this right, but so that's a good question. So getting IoT data into a smart contract, that's a really good question, actually. Basically, what you would do is you would take your sensor and you would have it, you'd connect it via an API to your Chainlink node. Your sensor could just send the Chainlink node API calls, or excuse me, the Chainlink node could just make API calls to your sensor. And depending on the output of those API calls, you could deploy, you can make a smart contract do something. You could, or the other way around, depending on the output of a smart contract, you could turn on a sensor or do something with a sensor. So everything just flows through APIs. So with a sensor, for example, if you wanted to make it decentralized, you would have many different sensors. Like weather is a great one. If you wanted to get the average temperature of Boston, you just have many weather sensors, giving that temperature update to this Chainlink oracles. That's a really good question. And we've seen a couple projects who start working with IoT data for similar use cases. So that's actually really exciting. Are there samples to connect to NYC, Miami, date open data APIs to retrieve city data? Probably. I mean, honestly, if the API exists, you can work with it. So if you find an API that actually gives you that data, you can work with it. I don't know of any examples. Miami date open data APIs to retrieve city data. I guess it depends on what kind of city data. Something that is really interesting is we released a video on using Google's BigQuery. Google's BigQuery has a ton of free data, a ton of really cool data that you can use to combine with smart contracts to look up nearly anything or whatever's in their data library. But that's a really good question. So the question here is kind of more on sourcing data and where can I find data. If you can find the data, you can put it into the smart contract. Question from YouTube. I have an ERC20 token and want to use the best tools to make it an incredible asset. What aspects of Link could I use to add to this already deployed asset? So this isn't really related to Link so much, but I will say that the Link token does have a really cool feature called transfer and call. I recommend you checking that out. Yeah, that's a pretty general question. What aspects of Link could I use? Yeah, I would say look into transfer and call, or the ERC 677 standard actually. Question from YouTube: could you please tell the main difference between connecting two blockchains, private and public, using Chainlink and Polkadot or Cosmos? Main difference between using Chainlink and Polkadot or Cosmos. Between connecting two blockchains, private and public. So it sounds like you're confusing Polkadot and Cosmos for oracles. Cosmos and Polkadot aren't oracles. So I guess that would be the main difference. So that's not what they do. That's not what Polkadot and Cosmos does. So Chainlink is an oracle. That's what Chainlink's primary function is to get data from the real world, bring it onto blockchains. Unless you're asking what's the difference between connecting private and public blockchains, in which case I would say there isn't really a difference. Actually, we did a demo with a project, and we showed deploying a Chainlink node to a private blockchain. So if that's the question, you can absolutely 100% deploy Chainlink to a private and a public blockchain. I suppose you could use Chainlink to attest to states of different chains. You could, and that would be a really interesting use case. And if somebody builds that, I think that would be really cool. At the moment, that's not what Chainlink's primarily used for, but that would be really cool. And if you can build it, I would love to see that. That would be really cool. But yeah, sorry, I'm going to go back to the demo here, and I'll answer some more questions soon. So we're on the Coven network. Here's the address of, what do I have? 40 minutes left? I think we're doing good. Either scan Coven. So we're gonna head over to Coven's network. And we can see again, we can see this being updated. It's not as frequent because it's a test net, but we can see things being updated here. So what we do is we take this address and we add it to our aggregator v3 interface as a parameter in our constructor here. And then we can call this get latest price function, which these are the variables that get returned. And we're just going to do price feed dot get latest round data and just return the price. A common question is, why is an int? Why not a uint? And the answer there is, as more and more interesting types of data are onboarded, you're going to want negative numbers. So in Remix, we're just going to compile. Injected Web3, so we're going to use MetaMask here. Let's deploy it. Yep. And we'll get the link there. And this is our contract, and we get the latest price, and we can see this is the latest price of Ethereum, and boom, it's that easy. And then you can use this price to do whatever you want. Maybe you want to make a DEX, maybe you want to make update some type of update some value on your smart contract. You can do whatever you want with this price, because now you have this definitive truth, this decentralized reference point on what the price of Ether is. So that is that's the price feed. Let's look at the random number again. We're going to do Remix first, and then we'll switch over to doing like VS Code with a smart contract development framework, just to show you kind of the like if you wanted to start right from Remix. So same thing, we get this populated. We're going to import the VRF code, which is different. We're going to inherit everything from the VRF consumer base, and VRF is a little bit different. There's a little bit more to it than just the view function on the price feed. What we're actually doing is we actually make a request to an off-chain oracle. That oracle is going to generate a random number, post it back on chain. On chain, there's a smart contract that's going to verify if it's actually random based off on the node's key hash. Each node has their own key hash. And then if it's good, if it's a random number, it's going to output it to us. So before, the price feed was a number that was already generated on chain, and we were just reading from it. So here we're actually making a request to the node. The node is generating our request, and then it is making a second transaction back on chain for us. So it's a little bit more involved. But again, We have a couple different addresses in here. We have the VRF coordinator address, which is going to be the one that's going to be doing the verification and making sure the number is truly random. Link token address. And then we have our key hash of this oracle. So when we're choosing an oracle, we actually choose the oracle and we say, this is that oracle's key hash. That way they can't lie about if the number is random or not. And so here's our constructor. And since we're inheriting the VRF consumer base, we're going to the two parameters that it takes is the coordinator address and the link token address as well. And we're going to give it these two global variables, key hash and fee. Again, the key hash is the key hash of the oracle, and fee is actually the link that we're paying to the oracle to execute this request. So similar to how whenever you use logic on the Ethereum chain, that computation costs ETH in gas. Whenever you get data with Chainlink, that costs Link in what I like to call the oracle gas. So once we deploy it, we're actually going to call this get random number function, and we give it a user provided seed. So this is going to be a number that we come up with to kind of bounce off of, again, to check to make sure the number is random. And we're going to call this request randomness function, which, because we've inherited from the VRF consumer base, it kicks off that random number request to the Chainlink oracle. And again, like I said, we're making two transactions. The Chainlink node is actually going to respond on this fulfill randomness function. And you can see it's an internal override function, which means there's a fulfill randomness function that we're overriding to add these into it. Only the Chainlink oracle can actually call this and fulfill the random number. And we're just going to store the random number into this random result variable that we're going to read and see what the random number is. So let's go ahead and compile this. Inject a Web3. Let's deploy. MetaMask pops up. Can you guys see it when MetaMask pops up or no? Maybe not. I know you could before, but I know this is like a different window. In any case, MetaMask popped up. I think it
was different screen, yeah.
It was a different screen, yeah. So this is the same screen, but the other one's a different screen. So MetaMask popped up. I hit confirm. And now we can see this is our deployed contract here. Now, I'm going to hit this request random number, and it's going to fail. And I just want to show you this because the first couple times you might run into this. You're going to get this gas estimation failed. Again, remember, you don't have any Oracle gas yet. So we actually need to fund the contract with our Oracle gas, which is our link. So we're going to copy the address like this. We're going to go into our tokens. We're going to send it. We'll send it to Link just to be safe, even though the fee is 0.1, just in case we want to get a bunch of random numbers. Send it to Link. Here's our transaction. It looks like it's pretty much already gone through. Yep, it's gone through. So once it's gone through, now we can make the request because we have the Oracle gas to pay the Chainlink node. So we're just going to use 123 as a random number seed. In the documentation, there's a note about choosing a random number seed to keep it really secure. So you're going to want to check that out too. Don't always have it be 123. So let's do get random number. MetaMask pops up in a different window. We're going to confirm. And right now, before the node responds, our random result is 0. So we actually, again, we have to wait for 2 transactions. We have to wait for it to send. The Oracle's got to get it and then respond. It might be done already, but it also might not be. So once the random number comes back, you'll see we'll get a random number within the range of 0 to the max size of a uint 256. So this could be this most likely it's going to be a huge number. Another question that I get asked a lot is how do I take this random number and kind of divide it into other random numbers? You can use a module function and basically split it up by the digits and just have multiple random numbers to kind of do less requests there. And yeah, here we'll see it here. It's this massive random number. But this is actually wild because this is a provably random number, which is something that is so cryptographically wild that I think it's insane that we actually have the ability to do this. So this is how the Chainlink VRF works. Are there any questions about that? All right, cool. Let's move on. And now we'll move on to our last one, making a GET request. So this is just calling any API. This is where you can really customize your smart contract to do whatever you want. We are going to be calling from this API right here. And actually, if we call it right now, we can see what it responds. It responds with kind of this massive JSON object. And we're actually just looking for, we're going to try to get volume 24-hour. We're looking for this number right here. If you enter 123 again, I presume it will provide a separate random number. Did I already delete that? Oh, yeah, I already deleted it. Yes. Yes, yeah, different random number. But so this is where you can really customize however you want. I do want to point out really quickly, we won't have time to go over it here. External adapter Chainlink blog. But this is where you can really customize it and really make it your own. We have a blog on building custom external adapters. And what you would do is you'd build this external adapter and kind of make the API do whatever you wanted. And then you just swap this out with the URL from your external adapter, which is really, really powerful. There's, I know I mentioned external initiators as well. There's some documentation on external initiators. Those are a little bit more involved, but you can do some really cool stuff with them as well. So here we have our code for making an API call. We're going to import from GitHub as well. And same thing as the VRF, we actually choose our Oracle and we choose the job ID. So choosing the job is actually really important. This is going to define what is the return type of the job and what else the job does. So if you're looking for some custom jobs or some really interesting jobs, you can head over to market.link, select the network that you want. There's Matic, there's Binance here too, which is awesome. And we can say, if it maybe we wanted to find like an HTTP GET job that returned to uint, we can see some nodes that actually have that data, or maybe a GET job that returns a Boolean. We'd see some other jobs that some other nodes that have that job, and you click it, get the Oracle address, and then you could go to their jobs and find, for example, their job ID. So that Oracle address plus this job ID here are going to what you need to populate the Oracle and the job ID, and that chooses the specific node and the specific job. So, and again, same thing as the VRF. We're choosing a link token fee to give these guys out as a thank you for returning our data safely to us. So this is the constructor in here. We're actually going to call this request volume data, and there's a couple functions in here. So we build the Chainlink request by inputting the job, the return or the callback address, which is going to be this smart contract that we deployed, and then the callback function, which we're saying is defined as this fulfill function. So if we scroll below, we do see this fulfill function, which takes the request ID and the return data as its parameters. And again, this is why choosing the job ID is so important, because you need the job ID to return the same data type that your fulfill function has. It also has this record Chainlink fulfillment modifier, which means that only the Oracle that you specified can actually call this function. And then we're just going to set it to this volume parameter. So in this build Chainlink request, we're going to add some what's called adapters. So we're going to add a get adapter. We're going to say we want the job to get this URL. And again, we actually only want this volume 24-hour. So we're going to use this path adapter or this copy path adapter to walk the JSON to get to this volume 24-hour. So when we saw this response here, we see the first key is raw, the second key is ETH, third key is USD, and that's how we're going to walk to this volume 24-hour. So that's what we want. Then we want to multiply it because Solidity doesn't work with decimals. So we need to multiply it by a number high enough to get rid of all those decimals. And yeah, we add this times adapter. And then we send the Chainlink request. So we send the Chainlink request to the Oracle with the request, that request object that we built here, right? And we added the adapters too, and we add the fee. And then when it gets done, it's going to call via this fulfill function. So same thing, let's compile. Injected Web3, let's deploy. MetaMask popped up, I hit confirm. And we have deployed this again. Remember, since we're making a request, we have to send it link. So I'm going to send to link just to be safe. I should just max out the gas for these, right? Because it's a test net and I don't really care how fast it takes. But yeah, once it gets some link, then we can actually call this request volume data function, right? And this is what's going to make this API call. If we hit volume right now, it's a big 0. So let's hit this request volume. MetaMask popped up. It's on a different screen. Sorry. I'm going to go ahead and hit confirm, and it's going to give me the transaction here for EtherScan. So again, this is making 2 transactions on ETH. So it's going to make the transaction. The Chainlink node is going to read the event that's emitted. It's going to go get the data and go do whatever you tell it to do. I mean, at the end of the day, all these adapters are just saying, hey, do this, do this, do that. So it's going to go get that data. It's going to do whatever you tell it to do. And then it's going to return the data in a second transaction, which will actually update this number here. And it looks like it is already updated. And this is the volume for 24 hours there. So that's how you can get any API and get any data into your smart contract. Again, this example uses a single node and a single data source. So it's great for testing and it's great for developing, but in a production environment, obviously you want to use decentralized data because that's the whole purpose of developing with smart contracts. Got a question from Maximilian. But for external adapters, you wouldn't have an average or median of the data anymore, or not? I'm not sure I understand the question. So with an external adapter, you wouldn't have a definitive or a proven average or median, right? You're trusting that API and that single oracle is giving you this average, this median, and that's not what we want in smart contracts. We want to have trustless smart contracts. I mean, that's one of the whole reasons that we do anything with blockchain. What is the definition of an external adapter? An external adapter is anything outside of Chainlink's core functionality. So any adapter or task outside of Chainlink's core functionality. So if we go to the Chainlink docs, let me just go to adapters actually. So this is external adapters, which will tell you a little bit more about it. But if we go to adapters, these are some of the core adapters that the Chainlink node comes prepackaged with. So example, we can have compare, which compares values. We have copy, which is that kind of copy path thing that we saw. We have ETH bool, which turns a Boolean true or false into an ETH understandable Boolean. ETH bytes, which does the same thing for bytes. Int does the same thing for int. ETHTX, which makes a transaction on chain. Adapters, which are also known as tasks, are just something that you tell the Chainlink node to do. So an external adapter is something that you tell the Chainlink node to do that's outside of this core functionality, outside of the core of these adapters here. So an external adapter is where you build something yourself, hook it up to your Chainlink node and make it do something really cool. Good question. Can Oracle nodes whitelist consumers out of the box, or do they just respond to anyone using the Oracle address and the right job ID? They can actually whitelist consumers if they want. But out of the box, they just respond to anybody with the Oracle address and job ID. But again, if they set that fee, then they'll have to they'll charge the smart contracts for it. So, but you can whitelist if you want. I mean, because you use an API, that might be a centralized source for the external adapter. Yes. Okay. Got it. Good question. So you can make it do whatever you want, but you're still going, if you're getting data via an external adapter, in the same exact parameters apply, right? You're going to want to get that data from multiple external adapters from multiple different sources. Good question. Can you get notified by Chainlink when a price hits a certain amount without your contract initiating the request? Yes, actually you can. There are a couple different really interesting ways to do that. You can do what's called a cron initiator, which kicks off a job just whenever you set the schedule, and you could kick off a job that says like check for transaction, or you could do an external initiator where you build your own initiator looking for a specific thing. Yeah, maybe this cron job kicks off a quick script that you wrote that checks for prices. But yeah, you can have. I mean, this is the beauty of Chainlink. You can really make it do whatever you want to do. So yes, absolutely. All right, cool. I'm going to move on to my next demo because I only have a couple minutes left here. Share this one. So in a lot of my demos, I do NPM, I do Truffle, I do hard hat. I did want to show you guys a Python implementation actually of developing and deploying smart contracts that I really like because I'm a Python nerd. I love Python, which is Brownie. So could somebody please mute whoever's joined? Thank you. Yeah, because I love Python. I love working with Python. So that we have a blog coming out on this. You can definitely check out the Brownie docs on this as well. First, you'll need Python. You'll need Ganache as well. If you just have Python, you can just do pip install. I think it's ethbrownie. I'm not going to do it because I already have it. Next, what you'll need to do is actually install Ganache. I think this is the command. Everything for this is actually in the Chainlink docs as well. Hold on, I'm flipping to the docs. I know that you guys can't see the page. 1 second. Share. So here's the Chainlink docs. It does go over Truffle. It goes over adding, with NPM. You just add NPM install contracts, Chainlink contracts. You can do it with Yarn too. This will open up a Truffle project. And then here's how you do it with Brownie. You do need Ganache, so you have to do NPM install Ganache. So let's actually flip back now. And let me share my screen here. If we have time, we'll also do the Truffle demo. So once we have Ganache and Brownie installed, right, we can do which Brownie. You can see that we actually have it installed, or Brownie dash version, or maybe dash version is wrong. Oh no, yep. And so right now we have a blank folder, and Brownie has this cool thing called Brownie Mix, or excuse me, Brownie Bake, Chainlink Mix. And this will actually open up a smart contract project that already has some sample boilerplate code in it. It looks like I need to do this. Oh, right here. It already has some boilerplate code for our Chainlink smart contract. So you can go most of the smart contract development frameworks have a similar setup to this. There's like a build or an artifacts. This is where it stores all your already deployed smart contracts. There's a contracts tab, which right now this one comes pre-installed with with kind of the three main ones: API, consumer, price feeds, VRF, some images. This is a fun little Chainlink Brownie logo. Interfaces, which are really good for working with already deployed projects. And then we have scripts, which is what we're going to use to actually deploy stuff. And we'll get there in a second. You have your tests, and then the Brownie config, which will define a lot of stuff, kind of going quickly because we're running out of time, and the README. If you ever get confused, just go back to the README, hop into the Discord, leave an issue. We're very friendly, and the Chainlink community is really excited to help each other and have people be really successful here. So we can actually just go through the README too. You can actually just go through the README too to get started. Let's actually just scroll down to here. So we do need 2 environment variables. We do need to export Web3 Infura. I'm not going to do the whole thing. Infura project ID. Actually, I could just copy. I already have it. Exported, and this is going to be your Infura project ID. You can go to Infura, get a free key, and this is how we're going to connect to the Coven testnet. You also need your private key. So same thing. You're going to need to do export private key equals, whatever your private key is, cat, dog, mouse, whatever. You can get it from MetaMask or whatever wallet you're using. Just do export private key. Quick note from MetaMask is sometimes it doesn't export with like the first OX. So sometimes you have to add that on. And there's a link here if you want to learn more about environment variables and how to set them. And it's really, really useful for just kind of because a lot of projects use them. So we're actually going to deploy a price feed contract here. So we're just going to do Brownie run. And if you do nothing, Brownie should give you, oh wait, never mind, it gives you nothing. If you just do Brownie, excuse me, it'll give you kind of like a list of commands, and you can do Brownie help and see everything. Again, this is all in the documentation to read, and you can learn more there, but we're gonna do Brownie run, and we're gonna run our scripts. We're gonna run this deploy script, which you can see is a pretty simple Python script, which is going to just deploy, that's our API scripts actually, excuse me, which is going to deploy our price feed.deploy, and we're going to use Coven. So it's going to deploy the Coven ETHUSD. It's going to deploy a price feed using this Coven ETHUSD address. So we're going to do scripts, Brownie run, scripts. Am I in the right? Am I in the right folder? Oh, I'm not in the right folder. Brownie run scripts, price feed scripts, deploy, and then we're choosing the network. We're going to do Coven. So the same way we did with Remix, we can do it with here. Obviously, the huge benefit of using a smart contract development platform is you can do the tests. You can kind of script out everything that you want to do. Tests are obviously really important for keeping your project robust, and it allows you to kind of have this fully coded backend, and then you can put whatever front end you want on it as well. So it looks like we were able to deploy. So price feed deployed at here. If we want, we can also do Brownie console, but I'm just going to keep staying with the scripts because I really like them. So we also have this read price feed script, which we're going to run right now, and it's going to take the most recently deployed price feed. So this from Brownie import price feed, this price feed object is a list. We're saying grab the most recently deployed price feed, and we're just going to read from that. So same thing, we're going to do Brownie run, scripts, price feed scripts, read price feed, network Coven. And then this will say, hey, we're reading data from here, and here's what we get. And again, this is the price of ETH in USD. And remember, Slee doesn't work with decimals so great. So this is the actual price. So we have a little more than 1,200. So this is kind of a real quick way to work with Brownie to deploy your smart contracts. Again, it is pulling from my my test MetaMask account, which is how it actually deployed this on the Coven testnet. So that's that. And it looks like I do have some time left. Oh, you can go forever, Patrick. Oh, awesome. Got a couple questions. I'm flipping back to these questions now. How scalable is the Chainlink network? Really good question. That question can actually go a lot of different ways. So more and more, I mean, the Chainlink team is working, and the Chainlink core is working super hard on building, brand new features to, reduce gas costs, add more nodes, and do all these really cool things. And again, open source projects, so contributions are highly welcome, and you can see everything in the repo. But yeah, so Chainlink is right now, it's working mostly on Ethereum, and it's working mostly with popular cryptocurrency prices. But really, any data that's needed or wanted for smart contracts, Chainlink can add. And so right now we've seen fiat, cryptocurrency, but I'd love to see more diverse types of data get on. So that's one of the easiest ways and most exciting ways for me that Chainlink's going to scale is add more data types, add maybe weather data, add political data, like anything you can find in Google BigQuery on a smart contract, so we can build these insane smart contracts that can literally, replace current contracts, so we can have this more trusted environment using these trustless smart contracts. So that's one major way that I can scale. Another way is that Chainlink is blockchain agnostic. So you saw actually Chainlink is on Matic, who I believe is also sponsoring this hackathon. So if they are, and you saw that, maybe that's a little double whammy for you there, Chainlink and Matic. So that's another way Chainlink scales too, is being on multiple chains. Asking how Chainlink scales isn't the same as asking how like Ethereum scales, right? Because Chainlink itself isn't a layer one. Chainlink's a layer two, right? It's an off-chain resource that's getting data and bringing it on chain, the layer one aspect of it obviously is the link token that really secures the network and has some awesome improvements to actually make the whole thing work, like the transfer and call functionality. So so that's a good question. That's kind of a long. That's a really interesting question because of kind of the different directions we can kind of go on with that. But again, everybody who's here, feel free to hop into the Discord. The community is super active, always asking really good questions. And usually I'm around, and usually a lot of the people who work on the core is around, and you usually get answered pretty quickly. So and it's really friendly community. So feel free to hop into the Discord, and that's where the majority of the community is. So next question. Ultimately, Chainlink solved the trustworthy messenger issue, but what about the data source authenticity issue? Is there any work on creating a marketplace for getting real-world data such as temperatures, real-world data such as weather in a trustworthy way? Sorry if this was already covered, just joined in late. No worries. No, that's a really good question. So right now, the closest thing to that is market.link, which has you can choose the different oracles that you want and kind of literally build your own kind of price feed based off these different oracles, which is awesome. More and more projects are constantly adding different types of data and adding themselves to market.link. Like I said, the more nodes get spun up and the more people start contributing to the network, the more we'll see more and more of this. This is something we expect to come at some point. Kind of have this marketplace for data. Where you kind of show up and you just get this decentralized data. Right now, that marketplace is these price feeds, because these are pre-configured decentralized network that you can kind of just skim through and say, hey, I want ETHUSD. I don't want to have to build the network myself. And then you see all the transparency of that decentralized network. You can see it all right on chain over at feeds.chain.link. So that's a really good question. Like I said, more and more data is being added. Temperature, weather, those are things that are being worked on. It's interesting too, because Arbol is an insurance provider that's working with Chainlink to get kind of weather data to provide insurance for farmers. So I can only imagine that this is going to come a lot sooner, but maybe not as soon as we wish, but not as long as we might think. Yes, I also didn't understand that because the data from sensors is easily manipulated. Great question. So this is why you want a decentralized network of sensors. So in the same way that you're getting decentralized data for your price feeds, you're going to need decentralized data from the sensors. And so it's going to be for some of those trickier data sources. I'm really curious to see the solutions there on how people decentralize those. Like, for example, like what's the temperature of a heart in like an ice box, like you were saying, like if it's being or like an organ that's being transferred. I'm really excited to see the solutions that people come up with here, right? One kind of the easy one is just you add a whole bunch of different sensors that have totally different infrastructures into this box. In any case, it's going to be really interesting to see what some of the solutions that people come up with here. The easier ones is like weather data. If you have a city and you want the average temperature of the city, you can create thousands of these sensors all relaying this data to this Oracle node. That's just going to take the median of all these sensors. So for IoT stuff like that, it's actually really easy. The hardware part is the harder part. The Chainlink part and the Oracle part is actually the easier part. The harder part there would be like coordinating, adding all these sensors. How many nodes secure the link network at the moment? Good question. So right now, if you head over to market.link, and I'll even switch views here back to my internet browser, we can see some of the different nodes. Some of the different nodes on the different test nets. Again, this is Coven, but we go to mainnet too. Some of the different nodes and their activities. But if you want to see, so securing the link network is might be a little bit misleading because there's obviously many different networks because each one of these price feeds is potentially a different set of oracles. You can see XAU USD. I believe this is gold or silver. I forget. It's one of those. I should really know
Gold.
that. It's gold. Okay, cool. Thank you. Each one of these different oracles is bringing that data in for it. And so like this network, for example, has 9. So it depends on the feed. This one has 21, which is really exciting. And more, like I said, more and more advancements are being made. Like for example, when OCR comes out, there will be even more nodes because OCR reduces the gas costs by such an insane amount. So these are the ones that are securing like the feeds networks right now. But they're more than that, kind of just in the overall Chainlink community. What's the partition tolerance redundancy for data served? Good question. Well, for the price feed, unable to show price feed. Okay. Oh, it's probably updating or something. Maybe it's updating. Oh, that's pretty cool. Maybe I broke the front end. But yeah, you can actually see on the different price feeds, you can actually you can set your own deviations. You can set your own thresholds. It looks like this one updates every 86,400 seconds, or whenever there's a deviation threshold of 0.5% or more. So these nodes are actually monitoring the off-chain APIs that they're consuming, or most of them are actually monitoring many APIs to get a decentralized aggregate themselves, which is then again decentralized on-chain. They're monitoring it off-chain. And then if they see, hey, there's a 0.5% update, we need to update the smart contract to reflect this change. So it really depends on the network. It really depends on the price feeds. But yeah, you can set it to be really whatever you want. Is the data delayed by any amount of time? Is that just for price feeds? Yeah, so that's a good question. So the data is saying it's delayed, I don't think is accurate. But saying it's up to the second real time is also not accurate. So it gets each one of these has their own heartbeat, right? And whenever that heartbeat hits, it makes an update, or whenever there's a deviation threshold. So if I said it's delayed, that's not accurate, because anytime there's a significant movement, everything gets updated. So it's kind of this mix of being the price with basically 2 heartbeats. So, and the primary one obviously is the threshold, the deviation threshold. If there's a big spike or a big drop in price, it triggers a change. Sorry, this question might be too futuristic, but is there an adapter which can link quantum randomness sources to Chainlink? If it's got an API, you can do it. Long story short. So yeah. Do nodes get slashed for producing / voting on bad data? Yeah, this is a really good question, actually. So right now, nodes are basically monitored based off their reputation. If they behave poorly, they get kicked off these networks. If they are responding outside the range, outside the threshold, if they're not responding, and since the networks are pretty small, the groups are really swift to basically kick them off and bring somebody better in. Due to kind of, as the network grows, more and more nodes is going to be added to these networks, but due to kind of how small they are at the moment, they get kicked off really quickly to keep them in incredibly high quality, because that's kind of the main, there's so much money riding on these price feeds. I think it's something like $7 billion, $8, $9, $10 billion of DeFi is riding on these price feeds being accurate, which is fantastic. So, they've reached this level of decentrality that's really efficient for these protocols, like synthetics, right, like Aave. And but yeah, since everything's on chain, every oracle's reputation, goes right on chain. So if somebody screws up, if somebody doesn't respond, everybody sees. So, when you're running a Chainlink node, you really want to have a really high caliber. You really want to have 24/7 monitoring. There's a lot that goes into it, because if you're down for even a little bit, you're probably going to get kicked off. Very cool. Excited for some Graph Protocol Chainlink integrations. Yeah, I've actually seen a couple of those, which are really cool. I actually built a project that pulls from one of them, which is pretty cool. So cool. So I know we're at time, but Jacob said I can go as long as I want. Jacob, you have made a mistake. No, I'm kidding. Let me switch views again. So I know I showed you guys, showed everybody here, Brownie. This one is, yep, this was Python. We could do a couple different things here. Please hit us with more stuff. Okay, great. Let me ask, what would you guys prefer? Do you want to see Truffle? Do you want to see Brownie do other stuff? Do you want to see Hard Hat? I don't have a Hard Hat prepped, but I could get all the Hard Hat stuff really quickly. Is there something in particular you want to see Truffle? Hard Hat? Uh-oh. We're getting a battle. I'll show Truffle because Truffle and Hard Hat are pretty similar. Let me go to this. I've also written a blog and a couple of tools. If you Google, actually, let me flip back real quick. Q, who said Hard Hat. If you look up Hard Hat, Chainlink, I believe. Oh, yep, you'll get my repo here, which shows how to use Hard Hat and Chainlink. Which is Hard Hat is actually really cool because it's got this kind of like this forking thing built in. I definitely recommend checking out Hard Hat if you haven't before. But let's switch back. Yeah, I also wrote a blog recently on kind of the best smart contract developer frameworks, and I found that it's definitely going to be Truffle, Brownie, and Hard Hat. Hard Hat has some really cool improvements. So this is my Truffle. This is my Truffle file. This is similar to that Brownie mix. Yeah, if you haven't heard of Hard Hat, yeah, definitely take a look. It's really powerful. So this is my Truffle file. I already built it. Again, Truffle is from npm. So you do Truffle npm install -g Truffle, and this is how you get it. It's built into Scaffold ETH. Take a look at that. Oh, is it? Oh, I didn't know that. That's really cool. Yeah, actually, the forking feature is really powerful with Hard Hat. Truffle actually does have a Hard Hat, or excuse me, a forking feature. But I do like Hard Hat's a little bit better. It's a little bit easier. I didn't know Scaffold ETH had a yeah, here, I'll send you the link for the Chainlink Hard Hat one. I didn't know Scaffold ETH had a Hard Hat build-in. That's really cool. Yeah, Builder is now Hard Hat. Yeah, they recently rebranded, or Bidler, or however you pronounce it. That's why they rebranded, because it was like Builder, Bidler, what? Yeah, I feel like now we have to do Hard Hat. But yeah, so here's Truffle. This is made with Truffle on Box, smart contract kit /Chainlink, or excuse me, /box. Not going to do it again because I've already done it here. You can see everything in the README. Oh, actually, this is the outdated one. There's an updated one with price feeds and VRF, which is really exciting. So again, npm install. And everything's going to be in this config. So we're pulling from mnemonic and RPCRL. So mnemonic is going to be that cat, dog, mouse, cheese, whatever, from our wallet. So we export it from our Ethereum wallet, and then we export it as an environment variable in our project here. And then RPC URL, this is going to be, like your Web3 URL. Like if you add Infura, it's going to be the whole URL string for that. So we export those the same way as with Python, export RPC URL equals your www.infura.coven, or whatever it is. Again, if you're unfamiliar with environment variables, definitely check out that Twilio link in the Python Chainlink library. Now that we're bouncing around platforms and languages, we might get confusing here. But yeah, and then I believe, once you've unpacked everything, you can just run your basic Truffle commands. I've already compiled here. The README says to do the npm, but I believe you can just do the Truffle ones. So this is going to deploy this my contract, which is our API call thing. Again, the newer version of this has price feeds, I believe. So we'll do Truffle, exec or no, excuse me, truffle migrate dash network, or I think I said it's live on this one, right? Network live, yep. And then we're also going to do reset just in case. So reset, hard resets, even if you've deployed. So great, we're deploying to truffle, or excuse me, we're deploying to the Coven network right now because I have this RPC URL defined as Coven. And we're going to see the oh so familiar truffle deployments here. I'm going to deploy my contract, which my contract is just a little bit more advanced version of that API call bit that we saw. I should have updated this for the demo. Apologies there. Then we can do truffle exec scripts fund contract network live. We have a little fund contract script. This sends the link that that contract needs to make that to make the request to the Chainlink Oracle. So we're actually going to fund it, via script, which again is one of the huge benefits of doing everything in a smart contract development framework. We can just script everything that we want. Jason, I know you said I could go as long as I want. I will try to wrap. Sorry, not Jason. Jacob, apologies. I don't know why I came out as Jason. Jacob, I will try to not go too long. Be conscientious of people's time here. But so we just we funded it right there. We can actually go and see. Oh wait, can you guys see my VS code?
Yeah, it's coming through.
Yeah, it's coming through. Okay, cool. Yeah, we could see this if we copy paste it to Etherscan. I'm not going to do that because then I got to flip back and forth. But then same thing, we're going to do truffle exec scripts request data network live. And so this is exactly what we did in Remix. Just now it's all scripted out. You can see all the scripts in here. And this package is actually, this truffle box is actually really nice because the tests are phenomenal. And so if you want to see a really good way to write really strong tests in Web3, with any smart contract in general, definitely check out this My Contract test. It was made by Thomas Hodges, who's just a phenomenal smart contract engineer. So we've funded it with Link. We've made the request. We can see the request was successful. That means the link went through, which is great. And now we're going to do this read contract, which after we've made the request, the Chainlink node is going to fulfill the request, post the data back on chain, and we're just going to read from it. Again, truffle exec scripts read network Coven. And this should give us, I believe this is the price of Ethereum as well. And I ran into an issue. Unknown network Coven. That's because we said it's live, not Coven. And we got 0, and that probably just means it hasn't responded yet. We can probably check back in a minute. But that's kind of the basics of what you kind of look like here. Or you could do truffle console live, and this will bring you to the truffle console. And you can do all the same commands in your script here. So like I could do let MC equals my contract dot deployed. Oh, I need to do await, excuse me, because this is JavaScript. MC has already been defined. Let's do MC and CC. So I can do mcc.data.call, and this should give us the, right, because JavaScript does this weird stuff. Let's leave, or exit. I forget how to exit it actually. Control C, yeah. That's how you get into there. And is it just being really slow for some reason? All right, it's just being really slow for some reason and doesn't want to read, but that's how you'd interact with Truffle there. Going through the questions. Are there dApps actually using the VRF feed? Would you vouch for the VRF feed on record? XD, how is getting a random number not a standard contract on Zeppelin already? This is a really good question, and the answer is 100% absolutely. And I've written a couple of blogs about this. So there are there are basic ways to get a random number that are not secure, right? If you want to hash the block height and use that as your random number, absolutely. But as I said, if any of the miners have anything riding on it and they create the block that would give a different winner than what they wanted, well, then they just wouldn't publish the block, right? And so if you have a big mining group kind of doing this, now you've basically taken your fair lottery and it's completely ruined now, right? It's not fair anymore. So the reason that getting random numbers in computer science is hard, right? Because in computer science, systems are deterministic. Even when, like in your Python or your JavaScript, when you say get random number, normally what it does is it just looks at a location and it just reads some numbers, and because it says, okay, this is random enough, right? These deterministic systems can't create random numbers. Now, blockchain, where the entire thing is deterministic and everything is on chain, it's even harder, right? Because everybody can see everything. So saying, oh, I want a random number in a deterministic environment, it's not possible, right? So in order to get a random number, we actually have to look outside the chain to get a random number, because I see what your kind of question is here, right? So if you want to create a pseudo random number, absolutely go for it. Use the block height, use the block hash. But if you want to get a truly random number where your protocol is not going to get hacked and it's not going to get attacked, and again, this is something that we have seen where people use pseudo random numbers and their protocols are injured. That's the wrong word. Are injured because of it. If that's what you want to use, great. If you're building a random system or you're building a project that doesn't need a truly random number, go for it. But if you need a truly random number, if you're doing a lottery, maybe some random sampling, or maybe some high value gaming or even low value gaming, where you really want to have a truly random game, then you're going to need to use Chainlink VRF. And yeah, that's not why it's not an Open Zeppelin, because Open Zeppelin does on-chain contracts. So Open Zeppelin's awesome, by the way. If any of you guys are building any projects, definitely use Open Zeppelin for reference. They build amazing stuff. That's a really good question. That is a really good question. And the answer is because blockchains are deterministic, you actually can't get a random number, a truly random number, from inside the blockchain itself. I guess the Zeppelin deals with smart contract-based libraries. RNG is something that requires either VRF. Yep. It looks like, oh, yeah, I didn't even see that you guys answered this. That's why we invented lava lamps. Yeah, definitely interested in security properties of VRF. Yeah, definitely go check it out. There's some really brilliant people that worked on it. Jacob, I know that we've super gone over. If people are interested and if we have time, I will gladly show you guys hard hat. If not, we can jump off. Are there people who really want to see hard hat? Give it a second for the delay. All right, no, yeah, because hard hat's really similar to truffle, actually. Yeah, if you fork. Jacob, we have time to do hard hat, or should I just point them in the direction of the README there? Oh, we got 2 yes now. Is it okay if I do the fork?
Yeah, if it's like maybe 5 minutes, that's probably fine.
All right, cool. Yeah, I'll do the fork. You guys can all see my thing still. All right, cool. I'm gonna change screens real quick. Oh no. Welcome demos. Oh, I messed up. All right, 1 second. CD. Share screen. There's got to be a simpler way to do this. Chainlink card hat. Okay, cool. Everybody can see Chainlink card hat. So same thing, what's up? Yeah, VS Code. You can see me typing around and stuff.
Yep, you're good.
All right, great. So same thing, everything is in the README for a quick start if you guys want. You can clone this repo. Again, I can even drop it in the chat here. You can clone this repo. Everything's in the README. So we're actually going to be using this Alchemy mainnet RPC URL. So we're actually going to fork mainnet so we can deploy our contracts as if we're deploying it to a mainnet, which is wildly fantastic because we can work with mainnet price feed addresses, which is really cool. So same thing, we're going to export our Alchemy mainnet RPC URL and our mnemonic, exact same as before. You can see the example right here. And this is with Yarn. So we already cloned this. And in the hard hat config, we have this networks bit down here. And this is where we define the networks that we're going to be working with. And why I think the hard hat forking is so simple is because in your networks, we call one network hard hat, and this is going to be our default network. So whenever we run a script, we just don't say a network. It's going to default to this. We're going to say it's default hard hat, and the forking URL that we're going to use is this mainnet URL. So this is all you have to do to add forking in hard hat, which is why it's so fantastic. So you just do forking URL. You can also do a couple other things to get it, but this is the simplest way, and then you can add the other networks as well. So we have price feed here, and we have deploy. Oh, I didn't build a read. I didn't build a read command here, but what we can do is, we can run test. I forget what's in test actually. Not too much actually. We're working on updating this. But yeah, so we can do npx hard hat run, don't set a network, and then we'll do scripts deploy.js. It's what this is actually going to do, which is really cool. It's going to deploy this. Oh no, I added a read to deploy the deploy thing, which is really fun. I forgot about that. Yeah, at the price is wait, get latest price. Oh, cool. So we deployed it and we read. So this actually deploys. So hard hat has what's called a hard hat virtual environment, I believe, or hard hat runtime environment. You saw how fast that went. So it actually forked mainnet, and we used a mainnet address to deploy. This is our deployment script. Price consumer. Get contract we're deploying. Oh, in the contract itself, we're using a mainnet ethusd address. So it actually forked the mainnet, deployed the smart contract, and then read off of it back to us. So tests run really fast on hard hat because it uses this runtime environment instead of Ganache. And you can do this forking. So those are some huge pros that hard hat has, which is really cool. Hard hat. Algorand and Cardano use VRFs for the entire block production / selection of staking pools. So you can bet it's very secure. However, it all depends on the original seed data. Okay. Interesting use of forks. Yeah. This is probably my favorite use of forks because then you can test with mainnet. So that's kind of the simple overview of hard hat. Like I said, the setup is really similar. It has this hardhat.config, really similar to the truffle config. The difference is there you have these tasks. So I believe we can do hard hat accounts, and it'll print out the accounts. Yep. So hard hat is kind of the shortcut for it. And anything you add as a task, you can just add that task there. You can code whatever tasks you want and really make it do whatever you want to do. So I probably didn't even need to do the scripts deploy. I could have just set it as a task. But yeah, artifacts are up here. This is where a lot of the stuff is going to compile. You have your cache, node modules, obviously. And yeah, pretty lightweight. Also, Ethers.js. That is a yes. Yes, thank you, Jacob. Ethers.js is super clean. But yeah, I know I've run super over. And if there are any questions, speak now or forever hold your peace until you get onto Discord and ask it there. All right, cool. Well, that seems like it's it. Well, thank you all so much for coming and asking these really insightful questions. I'm super excited to see what everybody builds. This is going to be a fantastic hackathon. The ETHGlobal team always puts on a stellar event. We're really excited to be here and be participating. And thanks so much, Jacob, and the whole team for having us here.
Awesome. Nice to have you, Patrick. Thanks for going all over all of that. And yeah, again, also thanks for Chainlink being a sponsor of this event. And you guys have been on so many of our events, and it's been amazing to work with you guys for so long. So thanks for coming back, and looking forward to see what people build on Chainlink. Thanks, everybody.